Hey, it's Trip here from the 87th. This video is about the climb profile in BMS 4.33. Information is current as of update 1. My wing has chosen a climb profile as SOP of 350 knots, transitioning to Mach 0.80 for the climb to altitude. So what this means is we are going to climb initially at 350 knots until such time as the Mach indication in this part of the HUD reads Mach 0.80, and then we'll forget about climbing at a calibrated airspeed of 350, and we'll just reference the 80 and maintain a constant 80 as we climb to altitude. So we're pretty heavy today. We'll be using afterburner at 300 knots. We'll pull the power back to 95%. I have RPM in the lower left corner of the HUD here, but if you don't have that, then you come over to the RPM gauge and set 95% here. Some people use 725 degrees fan inlet temperature on the FTIT gauge. I find it kind of hard to set because it's hard to see and hard to precisely get 725. So 725 equates to 95% in this block, so that's what I use. Alrighty, so we're going to climb at 80 eventually up to altitude, but what altitude are we going to climb to? Well, in the mission schedule page when we're briefing the mission, or maybe you made the TE and you just kind of arbitrarily said, all right, we're going to level off at cruise at 27,000 feet. All right, we really don't have any good flight planning tools there, but when you come into the airplane as flight lead, if you go to ICP button number 5, which is the cruise button, and you hit it until it says home here, it'll tell you the optimum altitude for your gross weight and your drag index, and that's what this number is specific to, your gross weight and drag index. As those two things decrease, this number climbs higher. So right now it's saying that our optimum altitude is 24,000 feet. So as flight lead, I've kind of got that number in my hip pocket, you know, and I'm thinking, all right, we're going to level off around 24,000 feet. There's really no sense in climbing higher or leveling off at some lower altitude, because it would be not as fuel efficient as being at the optimum altitude. And if you're on a long mission where there's no tanker coming up or going up or coming back, and fuel is kind of critical, you might want to think fuel conservation and not climb much higher than this altitude here. If you make the home page the active page by hitting this ICP button 0, which is mode select, it will put carets in the HUD. It'll put one caret on the altitude scale and another caret on the airspeed scale. Now you won't see these carets until you're airborne with the gear up, and then they'll come into view. They'll always have this number here, so at any time you can refer to this altitude, 24,000 feet in this case. Alright, now when the airspeed caret comes up, it's going to be indicating quite a low airspeed. So what it's saying is if you want the best performance and get to wherever you're going with the most amount of fuel when you get there, then you need to fly at this altitude and this speed. Well, this speed's going to be a little bit too low for us because, you know, we're crossing the flotte maybe, or getting close. We're going into combat. We don't really want to be going slow. We want to be going fast. Speed is life, as they say. So we're going to fly at a much faster speed than this, but at least we'll be somewhere near the optimum altitude. So we're trying to be as efficient as we can, but we're choosing to fly a faster airspeed. Alrighty, so let's release the brakes and take off. Now, every time I start a takeoff roll, I always think that about the limitation on the tires. It's 205 knots on the ground. You can't go faster than that, otherwise you exceed the rotational speed of the tires. So you want to be airborne before 205 knots And we made it off there. So we're going to accelerate around 2 to 2.5 degrees of nose up until we pass 300, and then I'm going to set the power at 95%, and then continue to accelerate to 350, plus or minus 5 knots or so. It's not too critical, but the 0.80 is going to be critical. You don't want to be more than a 100th off there, so try to keep it around 80 the best you can. And so in the low altitude structure, this 350 knots is the most efficient speed to climb at. And then when you get up to the higher altitudes, you're transitioning to a Mach number, because that's going to be the most efficient climb speed. What you don't want to do is, for instance, announce to your flight crew members that you're going to hold 5 degrees of nose up pitch and maintain 350 knots in the climb. Well, you can do that, certainly, but that's not really even a profile, and it's very fuel inefficient. There'll be times when you're on the radio telling your flight members, okay, we're going to level off here and gain some speed because our speed got real low in the climb, and okay, we're going to climb now at 5 degrees and 330 knots. I mean, it's just, there's no problem with that, other than when you make those calls, you may be stepping on or blocking somebody's transmission on UHF that has something important to say. So this eliminates that problem. And your flight members know exactly what the profile is. They don't have to ask you what your airspeed is. They don't have to ask you what your pitch attitude is. Your pitch attitude is whatever attitude it takes to hold 350 knots, or 0.80 when you get to that point. If they asked me what my pitch attitude was now, I could tell them, but 2 or 3 minutes later it's going to be different. So it's just a senseless call, to garbage up the radio with. And besides, your wingman should have you soft locked in TWS, and that way on the FCR they can read, your airspeed. And if they have to ask you what your pitch attitude is because they're behind or they're too low, or they need to light the burner and get up, into formation. If you briefed a fighting wing, then they need to, step on the gas and get up here. Now, when they're in formation on your wing and you're climbing out in formation, then obviously your pitch attitude is the same as lead's pitch attitude, so they don't have to ask you what your pitch attitude is. So light the burner and get up there and get in formation. All right, we're at 6.8 Mach now, accelerating. Now, I happen to know that this combination of 350 and 80 will give me a crossover altitude of 23,000 feet. 23,000 feet is not an important number, other than it's just a reminder that as I approach that altitude, it kind of reminds me to be looking at Mach number for the continuation of the climb as opposed to the calibrated speed. So every combination of calibrated and Mach will have a different crossover altitude. You can use any combination you want. If you want to climb at 380 and transition to 8.3 Mach for the climb, that's fine, and it'll have its own crossover altitude. That one's 21,000 feet, but you don't have to memorize those. I use 350 and 80 a lot, so it's easy for me to remember that 23 is the crossover altitude. All right, very good. So this crossover altitude, it's not dependent on gross weight and drag index. It's always going to be 23,000 feet, in our case 350 and 80. It's always going to be around 21,000 feet for 380 and 83. But the optimum altitude from the home page here, that is dependent on gross weight and drag index. See, my pitch attitude's quite a bit lower than 5 degrees, but that's okay. You know, I'm holding 350 knots as briefed. So don't get slow in the climb as lead. You know, if you're ahead of schedule and you need to waste some time, you know, don't slow up to like 240, 250. That's kind of slow in a fighter. Just do some S-turns, or maybe give yourself a little vector off course and then back to the target when the speed requirement gets a little bit higher. And you know that how that's going to occur is if you go to the time over steer point page, you can read the time or the ground speed down here that's required to make this desired time over steer point. And when you have this page as the active page, by hitting mode select, it'll put this this caret will be referenced to a calibrated speed. So when this caret is centered, when you center this caret, you'll be doing this required ground speed, so you don't have to keep looking down here. You don't have to be on this page. All right, there's 350 and 80, and there's about 23,000 feet. So now we just climb at 80 Mach, and we forget about indicated. I say indicated, it's calibrated speed, it's just what's indicated on the scale. That's why it's called indicated airspeed. All right, so you can see the calibrated speed, the indicated speed is dropping as we maintain 80, and it'll continue to drop as we go higher, you know, much higher. This can get down, you know, quite low, down around 300, 310. But that's okay because we're doing Mach 80. We're going like a bat out of hell. We got great climb performance. We're going to be able to climb higher and quicker than if we had tried to maintain 350 knots at this power setting. So this is, in the high altitude structure, you always refer to a Mach number for your climb speed. So we're down to 337 and still got well over 2,000 foot per minute rate of climb. So the question is, well, how much higher do I climb? And my answer is I stop climbing when my vertical climb gets to 1,000 feet. When it drops down to 1,000 feet, that's when I level off and accelerate to a cruise speed. I want to give myself a performance margin. I could keep climbing until I had like 200 or 300 foot per minute rate of climb left, you know, and that's all I had. But I'd be kind of hanging from the pitot tube, and you know, when I tried to make a level turn, you know, I wouldn't be able to do it. The airspeed would drop off real quickly, and even this turn here is really eating into our climb performance. So I give myself a performance margin of 1,000 foot per minute rate of climb. You can use 1,500, or you can stop your climb at 2,000 feet a minute. It's just whatever you choose. But we're almost there. I'm climbing at 80, and I've got, you know, right around 1,000 feet. So I'm going to level off right here, stick the autopilot on, and let it accelerate to a cruise altitude of maybe 8.3 or 8.4. That's a respectable cruise speed. So pull the power back to maintain that speed. Now let's take a look here. Let's say that I'm going to use steer point 5 as our target. This says we're going to get to, I plan to be there at 30, but we're going to get there at 33, so it's requiring, this is the active page, so it's requiring quite a bit more airspeed here. I don't want to go that fast. So I'm going to coordinate with the mission commander, and since I'm the strike flight, you know, guy dropping the bombs, I'm going to tell the rest of the package what time I want to be over the target. So I'm going to have to adjust that. So we plan to be there at 30. We're going to get there at 33. I'm going to add 6 minutes to all my steer points. And the way I do that is I come over to the ICP button number 6, the time button, put the asterisk around the time over steer point differential, and then I type in, what did I say, 6 minutes? I type in 600, and then enter. Now if I needed to take time off, I'd have to hit this ICP button number 9. There's a little minus sign there, so that's how you enter negative time. But in this case we're adding positive time, so I'll hit 600. Now let's go back and check the time over steer point. Alright, now I want to be there at 36, and it says I'm going to be there at 33, so now I've got a little bit of time to waste. It's telling me I need to slow up. I don't want to go that slow, so I could do my S turns here, or I could give myself that vector off course and then back on course when the carrot crept up a little bit higher, or I could do a right 90 or a left 90 and waste time that way, and then turn back on course when this carrot started coming back up the line here. Right now it looks like it's about, what is that, 270 or so. So that's not really a good thing. So I'm going to turn left here about 90 degrees or maybe less. Let's see if we can watch this carrot come back up the airspeed scale. When you turn away significantly from the target, then that carrot's going to start rising up the scale. I wouldn't do a 360 here. You can get in a little bit of trouble there because you could, your estimation could be wrong, and by the time you roll back out toward the target, now you're really late. So now you just have to do another, Rolex adjustment. That's what it's called, Rolex. In this case, Rolex plus 6 would be the call. So everybody would perform the same operation on the time page and increase all the steer point times by 6 minutes. Alright, so the ground speed required is coming up. That means this carrot is going to be coming up also. So I'm going to roll out here and let's see what happens. Give it a little bit of time here. Hopefully this won't take too long. Turn a little bit more. Just going pretty slow here. Well, this didn't have anything to do with the climb profile, but since we started talking about it, I got to finish it. Alrighty. Well, I can see the carrot starting to move. Still too slow to be turning back. Tempted to do a 180, another 270 to the left, but that's kind of risky. Now I don't have to be on this page. I don't need to be watching ground speed. All I need to be doing is watching this carrot. When it gets to 300, I'm going to start turning back. See how that works out. So maybe I could stop it at around 350 or so, which would be a decent time, decent speed. Right now 340 is giving me 8.3, so let's see how we can do this. Alright, well that's going to work out pretty good. About 350 it looks like. .84. Yeah, that's good. That's a decent it's a decent speed, 8.4 Mach for a fighter. All right. Well, I'm glad we completed that, and I hope you got something out of this discussion on climb profiles, and trip out.